Let us look at a few MCQs. First one, KH value for some gases at the same temperature T are given. The gases are argon, carbon dioxide, HCHO, that is formaldehyde, and CH4. And their KH values are given. Where KH is Henry's law constant in water, the order of their solubility in water is. We have to choose the correct order. Now we know that KH, or the solubility of a gas in water, is inversely proportional to the KH value. So the higher the KH value, the lower will be the solubility of the gas in water. So which one is having the highest value? You can see argon is having the highest value. So it will be having the lowest solubility. So two such options are there. Argon having the lowest solubility. The next one is carbon dioxide. So option A is the correct choice. Carbon dioxide, then methane, and then finally HCHO. So option A will be the correct choice. Question number 2. For the cell reaction 2Fe3 plus aqueous plus 2I minus aqueous giving 2Fe2 plus aqueous plus I2 aqueous. E0 cell is given as 0.24 volt at 298 Kelvin. The standard Gibbs energy delta Rg of the cell is given that Faraday constant F is equal to 96,500 coulomb per mole. So we have to find, what formula will we use? Delta Rg is equal to the formula minus NF E0. So N we need to find the number of electrons involved in this. So let us just write the equations. Fe3 plus giving Fe2 plus, and the next one is I minus giving I2. So Fe3 plus giving Fe2 plus. So there is the discrepancy of one charge, isn't it? This is 3 plus and this is 2 plus. How will we balance it? We put an electron here. Here it is I minus and this is I2. So that means this, if we put 2E minus here, 2 electrons in here, this will be balanced. Now we have to equalize the number of electrons. So the number of electrons involved is 2. We can directly get it from the equation, but those who are finding it difficult, number of electrons, that is N is equal to 2. Now it is direct application. So delta Rg equals minus 2 into F. F is given as 96,500 coulombs into E0. E0 is given as 0.24. So if we do the calculation, we will get the answer as minus 46,320 joule per mole. The answer is given in kilojoule per mole. So put 1, 2, 3 decimal here, minus 46.320 kilojoule per mole. So that is option D. D is the correct choice. Next is zirconium. Z is equal to, that is atomic number is 40, and hafnium atomic number is 72, have similar atomic and ionic radii because of having similar chemical properties, belonging to same group. See, diagonal relationship, D. Lanthanoid contraction. We know that both of them are lanthanoid elements. So, what could be the reason? So, the lanthanoid contraction is the reason why they are having more or less the same atomic ionic and atomic radii, because this lanthanoid contraction causes the radii of the members of the second and third transition series to be very similar. So these elements belong to the second and third transition series, and so because of lanthanoid contraction, their radii, ionic and atomic radii, are similar. Next one, in a typical fuel cell, the reactants R and products P are. So the fuel cell which you have learned is the hydrogen fuel cell, hydrogen oxygen fuel cell. The reactants are hydrogen and oxygen, and the product which you get is water. So hydrogen gas and oxygen gas and water is the product. So option B will be the correct choice. For a certain reaction, the rate equals K into concentration of A raised to 2 into concentration of B. When the initial concentration of A is tripled, keeping the concentration of B constant, the initial rate would. We need to find whether it will increase by a factor of 6 or increase by a factor of 9 or increase by a factor of 3 or decrease by a factor of 9. So let us write the first rate, that is rate in the first case R1 equals K into concentration of A raised to 2 into B. And in the second case R2 equals K into what happens to the concentration of A? A is tripled. That means A becomes 3A. Now concentration raised to 2 into concentration of B. That is equal to, we can write it as 3 squares 9. So 9K into concentration of A raised to 2 to concentration of B. So this is 9 times, or R2 is 9 times R1. So it increases by a factor of 9. Option B will be the correct choice. Next is an assertion reason type question. Assertion is a catalyst increases the rate of a reaction. Reason is the catalyst increases the activation energy, which in turn decreases the rate of the reaction. In the light of the above statements, choose the most appropriate answer from the options given below. So assertion is a catalyst increases the rate of reaction. That is correct. A catalyst increases rate of reaction. How does it increase? By lowering activation energy of reactants. So our reason given is the catalyst increases the activation energy. So that is not correct. So our assertion is correct, but the reason is wrong. So assertion is correct, reason is incorrect. Option C will be our correct choice. Next is identify the incorrect statement. Incorrect statement. The transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. That is correct, isn't it? Transition metals show variable oxidation states. Interstitial compounds are those that are formed when small atoms like hydrogen, carbon or nitrogen are trapped inside the crystal lattice of metals. That is also correct. The oxidation states of chromium in CrO4 2- and Cr2O7 2- are not the same. That we will check. Cr O4 2 minus. Let X be the oxidation state of chromium plus 4 oxygens. 4 into minus 2 is the oxidation state of assigned to oxygen. Minus 2 equals overall charge of minus 2. So X minus 8 equals minus 2. X equals minus 2 and this plus minus 8 will become plus 8 here. So it will be plus 6. What about in Cr2O7 2 minus? Cr2O7 2 minus. 2X, 2 chromiums are there, plus 7 oxygens are there. 7 into minus 2 for each oxygen equal to minus 2. So 2x minus 14 equals minus 2. 2x equals how much will we get? Minus 2 and this minus 14 will become plus 14 here. So that is equal to plus 12 and x equals plus 6. So in both cases it is the same. The oxidation states of chromium in CrO4 2 minus and Cr2O7 2 minus are not the same is given. So they are the same. So this will be the correct choice. Let us look at the other also. Cr2 plus, that is a D4 configuration, is a stronger reducing agent than Fe2 plus, that is D6 in water. Yes, if it is D4, then it will try to get a better more stable oxidation state. So this will be a stronger reducing agent than Fe2 plus. Next is 8. Cn minus is a strong field ligand. This is due to the fact that it carries negative charge. It is a pseudo halide. It can accept electrons from metal species. It forms high spin complexes with metal species. So Cn minus is a strong field ligand. Now that is due to the fact that it can accept electrons from metal species. That is, it can form pi bonds by back bonding. That is, by accepting electrons from metal ions, and they can form pi bonds. So option C will be the correct choice. Next is the geometry and magnetic behavior of the complex NiCO4 times R, that is nickel tetracarbonyl. The options are given to us. Let us say nickel atomic number is 28 and its electronic configuration is argon 3d8 4s2, and we can see four S and 4p also we will draw. So it has 2, 8 and 2 here. What happens? It will send these 2 electrons in here and you will have a completely filled 3D set of shell orbitals. And this S and these P will be occupied by CO. So you will be having sp3 hybridization. So that means you will be having tetrahedral geometry. And are there any unpaired electrons in here? No unpaired electrons. These are all occupied by 2 electrons each, like this, of the carbonyl group. So option B will be the correct choice. It will be having a tetrahedral geometry, and it is diamagnetic. Now this compound, the given compound, is an example of aryl halide, allylic halide, vinylic halide, or benzylic halide. You know that this carbon carrying this halogen is connected to another carbon which is connected by a double bond, or which is having a double bond on it. So it will be an allylic halide, or it will be an allylic compound, halide. Now the next one is question number 11. Which of the following will not undergo SN1 reaction with OH? So SN1 reaction will be most favorable in a more stable carbocation. So we have to see which will be, say, option C. If we look at each of these, we can see that option C will be a primary halo compound, whereas A is allylic. There is possibility of resonance and thus stabilization of the carbocation. And this is tertiary. This is also very favorable for SN1. And then benzylic. So all these except C. C is primary, will give you a primary carbocation, at least preference for primary. So which of the following will not undergo SN1 reaction with OH? So option C will be the correct choice for question number 11. Again, we have an assertion reason type question. That is, given below are two statements. In Lucas test, primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with concentrated HCl and ZnCl2, known as Lucas reagent. Primary alcohols are more reactive and immediately produce turbidity at room temperature on reaction with Lucas reagent. In the light of the above statements, choose the most appropriate answer from options. So we know that Lucas reagent is used to distinguish between, is a test used to distinguish between primary, secondary and tertiary alcohols. But it is the tertiary alcohols which are most reactive and immediately produce turbidity at room temperature. So option C, that is statement 1 is correct, but 2 is incorrect. Option C will be the correct choice. Next is question number 13. RMgX plus CO2 in dry ether will, on acid workup, will give you carboxylic acid, RCOOH. What is Y? That is RMgX plus CO2 in dry ether is giving you the compound or the intermediate Y. What is Y? If you write it, RMgX, that is R is having negative charge, Mg a positive charge, and it is reacting with carbon dioxide. See, double bond O, oxygens have lone pairs, but this carbon, so oxygens are electronegative also, so this carbon will tend to have a positive charge and it will come and attach to this here, and one bond will move here, O minus you will get. So what will be the product which you are getting? R C double bond O, O minus, and Mg plus X. That will be the intermediate which you are getting, that is Y. Do we have an option? Yeah, this is it, RCOO minus Mg plus and X. So option A will be the correct choice. Now this is vitamin B2 is also called. Is it thiamine, riboflavin, pyridoxine or ascorbic acid? Ascorbic acid, you know, is vitamin C. And thiamine is B1. Riboflavin is the correct answer. This is B2. And pyridoxine is B6. Thiamine is B1. And this is vitamin C. And another vitamin, that is B12, is there, and that is called cyanocobalamin. So that is it. Now, question number 15. The correct IUPAC name of the given compound is. So this is a carboxylic acid. So let us give this carbon number 1, and this will be 2, 3 and 4. Now if we look like that, there are 3 methyl groups on the second carbon. So it is 2,2-dimethyl butanoic acid. How many carbons? 1, 2, 3, 4. So 2,2-dimethyl butanoic acid will be the correct option or the correct name. Again, next question, that is question number 16. Which of the following statements is not true about glucose? It is an aldohexose. It contains 5 hydroxyl groups. It is a reducing sugar. It is an aldopentose. No, it is an aldohexose. Glucose is an aldohexose. So we are asked not true. Statement which is not true. So this is not an aldopentose, but it is an aldohexose because it has 6 carbons.